Hi, so today we're going to go through the PAT paper from 2016, looking at question 18. So question 18, we're told the drag force in the sphere is related to its radius r, its velocity v, and coefficient of viscosity, this symbol here, by F equals k times r to the x times this symbol to the y plus v to the z, for dimension as k. And we're told if the units of this symbol are kilograms per metre per second, we're asked to find the values of x, y and z for which this works. And we're told that x, y and z are integers. Now what we're going to do is we're going to perform dimensional analysis. So what we have to do is, well, if you haven't seen this already, watch our video on this to understand fully what's going on. But we're going to convert all of our things into units of length, mass and time. So let's do that. Well, we know that force is mass times acceleration, and therefore the dimensions of force, which we'll denote by square bracket, is dimensions of mass, which is capital M, and dimensions of acceleration. Well, we know acceleration is meters per second squared, so that's length times time to the minus 2. Okay, well, we know that k is dimensionless, and well, r is a length, so we know that the dimensions of r is 1 length. The coefficient of viscosity we're told is kilograms per meter per second. So that has units of mass times length to the minus 1 times time to the minus 1. And then we're given its velocity. Well, that's meters per second. So that's length time to the minus 1. Okay, so we sub that in. So get the dimensions of f must be equal to the dimensions of k, r to the x, simple to the y, v to the z. And therefore, m, l, t to the minus 2, dimensions of force, is equal to k we ignore because it doesn't have dimensions. So we have r to the x, so that's l to the x, times the coefficient of viscosity to the y, so that's m, l to the minus 1, t to the minus 1 to the y, times velocity to the z, so that's l, t to the minus 1 to the z. Well, what we're going to do is we're going to group them together. So that's equal to L to the power of x from here, minus y from here, plus z from here. So x plus z minus y. Similarly, we'll group the mass together. We only have one mass, that's mass to the y. We'll put that at the front because that's what the side it's on in the force. That's m to the y. And then time. So we have from here we have a y to the minus 1, so minus y, and we have a minus z. So that's to the power of minus y plus z. And now we can equate across. We know dimensions must be consistent. So we know y must be the same as the power of m here. This was the same as the power of l here. This was the same as the power of t here. So this implies, well, looking at the powers of m, we see clearly y is 1. And also from the powers of L, x plus z minus y equals 1. Also from the powers of t, minus y plus z equals minus 2, or y plus z is equal to 2. Well, this equation here implies, because y we know is 1, that z is equal to 1. And then this implies that because y is 1, we get x plus z is 2, or x equals to 1. Therefore, x equals y equals z, which is equal to 1.